Hello guys, and welcome to Euler 41 Pandigital primes. We shall say that an n-digit number is pandigital if it makes use of all the digits 1 to n exactly once. For example, 2143 is a 4-digit pandigital and is also prime. What is the largest n-digit pandigital that exists? This is quite a fun problem to solve because there's just so many ways you can solve this problem. First, you can lavish lexicographic permutations that keeps the order that we saw in one of the Euler projects. We can also use the sleeving method for generating primes, or we can just use the regular permutations. So I'm going to pick one of those methods, and then we're going to go ahead and implement that. So what I decided to go with is just the regular permutations, and then we're going to go ahead and speed things up by using threads. So I went ahead and provided you guys with a permutations class. It generates a permutation. The reason why I'm giving you guys this is because this problem is not solely focused on permutations. All right. So like I said, you can use sleeving for this to solve this problem. However, I don't want to spend time explaining to you guys how to generate permutations because I just feel like it's going to take way more time to explain. And there are many resources online that you can find that talk about permutations and efficient ways that you can actually generate permutations, like backtracking. All right. So the first thing I'm going to do is we need to create a helper class. So I'm going to go ahead here, create a Java class, and I'm going to call this one helper functions. So the helper functions are just going to go ahead and define the is prime and the is pandigital functions or methods. So static boolean is prime. We're going to take in an int value and just going to go ahead and implement it. So I'm going to say if value is less than 2, then we're going to go ahead and return false. We're going to say if value and 1 is equal to 0. So if the number is even, we want to return false. The reason is because since we already have 4-digit pandigital given to us, we only need to calculate a 5th, a 6th, a 7th, 8th, and 9-digit pandigital. All right. So that means that anything over 2 is an odd number prime, so we don't need to check the even numbers. Next thing we want to do is just get a final bar. We're going to do a limit here, which is going to equal, it's going to use the math dot square root and pass in the value here. Let's create a for loop. Let's say for var div equals to 2, and if is less than or equal to the limit div plus plus. So if the value mod div is equal to 0, then I'm going to return false. Return true. All right, and then for the next part, we just need to go ahead and calculate for the pandigital number, which is also going to be boolean. So it is pandigital. I'm taking the value as well. So the first we need is a counter because we know that we're going to have 9 values. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can create a counter array. We're going to say counter equal to new int, and we can just use some bit shifting here. So this is going to be 0 to 9, and then what we need to do is keep a remainder. I'm going to say remainder. You know what? It's fine. We don't need to do this outside. Let's just go ahead and do this inside. So let's reverse the number mathematically. So we're going to say while the value, right, is not equal to 0, we're going to go ahead and get the remainder. So we're going to say var remainder. It's going to equal to value mod 10. Next, we're going to say the counter, and we're going to go ahead and increment by the remainder subscript. We're going to say that if counter and the remainder subscript is greater than 1, so if we've seen the number twice, then let's go ahead and return false. Then we need to go ahead and reduce the number if it passes, let's say, value divided by equal to 10. And then here we're going to go ahead and return true. All right, so pretty much we're done with the helper class. Next, we need to go ahead and implement a thread class. So we could just call this one perm thread. That's fine. All right, so in this perm thread, we're gonna make sure that we implement runnable, and we need to, why is this not showing? Let us implement the run method here. All right, so we need some members in here. The first thing that we need is the string input for our permutation. So this is going to be string here. We're going to call this one input. And then we need to keep track of our max permutation for that input. So this is going to be an int. We're going to call this one max pan prime. All right. Then we need to go ahead and create a constructor. This is going to go ahead and take in the input, and let's initialize the field for this class. So we're going to say this dot input is going to equal input. All right. So the next thing we need to do is to implement the override it method, and we're going to go ahead and just create a set. This is going to be the permutations, and then we're going to go ahead and get the permutation, and this is going to be the input. The next thing we want to do is that we could just let's assert to see if the set is not equal to null, just in case we do something stupid and it doesn't pass. And then what we need to do is go over the values in the set. So I'm going to say var, var, and let's go ahead and traverse the set. I'm going to say that if the helper function that is Pandigital, but before that, let's go ahead and create an int value. So this is going to be, let's just call it integer. It's going to equal to integer dot parse int, and we're going to go ahead and pass in val here. So now we can use integer here. So we're going to say that if the value is Pandigital and it's also prime, then so integer here. So if the value is Pandigital and prime, then we just want to keep track of the max. So in here, let's go ahead here and initialize our max span to equal to 0. So here we're going to say that the max span is going to equal to math.max. We're going to go ahead and pass in the integer and the max span prime here. All right, and then all we need to do is pretty much get our we're going to generate a getter just to get the max span for this. So I'm going to go ahead and get the max span here. All right. And this is pretty much it for this class. Yep, it should be it. So that. Okay. So what we need to do now is pretty much just create a test class, or we can say we do largest Pandigital prime here. All right. Here we're gonna go ahead and create. Let's do a private int. Let's make it static. We'll do your largest Pandigital prime. This will take in no input. So we know that our Pandigital is going to equal 987654321 here. All right, that's the largest Pandigital number. The next thing I want to do is create threads for this. We're going to say var threads. We're going to equal to new thread, and we want to create 5 threads here. Okay. Like I said before, the 4-digit Pandigital number has already been given to us already. So all we're left with is to calculate the first 9-digit Pandigital, a 8-digit Pandigital, a 7-digit Pandigital, a 6-digit Pandigital, and a 5-digit Pandigital. All right. So that leaves us with just 5 threads. The next thing we want to do is actually create an array for the perm threads. So I'm going to say perm threads is going to equal to new permutation thread, and we're also going to go ahead and create 5 of those. All right, so now we're going to go ahead and also create a variable for our max perm here. This is going to be 0 as well. All right, so we can create a for loop. We're going to say for index equal to 0. Index is less than str dot length, right, minus 4. So we're gonna minus the first 4 pans because we already know what the value, the max pan and prime digit is for that range. All right, we're gonna do index plus plus. So what we need to do next is we're gonna go ahead and for our perm threads, and we're gonna pass in the index here equal to new perm thread, and here we're gonna pass in str and the substring pass in index here. All right. So what it's going to do is that it's going to copy the first 9 numbers, and then the next 8 numbers, the next 7 numbers, and so forth. Then we need to go ahead and pass this information to the thread, equal new thread. And here we want to go ahead and pass in the perm thread and that specific object. Next, we just want to go ahead and run the thread.run, and we're good for this portion. The next thing is to make sure that all the threads actually wait and they're finished. So we're going to say var thread in threads, and we're going to go ahead and do thread. We're going to make sure that they wait for every thread. And this is going to go ahead and throw an interrupted exception, and somehow it never is out. It's like when you want some of the features to work here, it never works. So let's go ahead and let's just do it manually. So throw interrupted exception. All right. So once this is done, we just need to go over the perm thread objects. We're going to say var pt and perm threads. We're going to say our max perm is going to equal math dot max. We're going to go ahead and do pt dot get max pan prime, and then we're going to go ahead and pass in our max perm here, and we just have to go ahead and return the max perm. So what we're doing here pretty much is we're just going through the numbers, and we're going and we're picking the first 9 and then picking the next 8 and 7. So what I'm going to do here is I'm going to go ahead and do a system out here, and let me do str substring and pass in index here, so you guys can see what's actually going on before we run the threads. And let's go ahead and do main, and then let's do SRT here, and let's pass in the largest pan, and then we also have to go ahead here and throw an interrupted exception. All right, so let's go ahead and run this, and this should be the solution for this problem. So you guys can see exactly what we're doing here. So we're calculating the Pandigital for the first 9 numbers. So what happens if we don't find one of the permutations to actually be a prime, right, for the first 9 numbers? Then the permutation is going to be the prime Pandigital is going to be somewhere within the 8 numbers. So remember that with permutations, if you have a 9-digit permutation, it's always going to give you 9-digit numbers. All right, so if you have an 8-digit number permutation, then you can have 8-digit numbers. So all we're doing is pretty much just choosing a random order, right, and we're rearranging the values, right, to get a new set of numbers, right? So pretty much that's what we're doing here. And then what we're doing here is that we're taking this, we're passing this to a thread, and that thread is going ahead and calculating to see if any of the permutations for this given number is actually Pandigital prime, and then storing that value for us. All right, so once we get those values, all we have to just do is go through each individual object, we find the largest Pandigital prime within those objects, and then we pass that to the max perm here. All right, so this code is going to be on GitHub. I'm going to go ahead and create a new GitHub account just for this channel, and this code is going to be on there with comments. All right, so if you have any questions about this problem, please let me know. I might also go ahead and add the sleeving method as one of, or adding maybe another file and have it in the on GitHub. All right, guys. Well, this will be it for this problem. And by the way, let me go ahead and run this again so you guys can actually see the answer. So this is the answer for this problem. I'll see you guys in the next tutorial. Bye-bye.